Perfect. Hi guys, how are you guys doing? My name, for those of you guys who don't know, is Nick Lindquist, and today we'll be going over the calculus inside the movie Mean Girls. Quick show of hands, who here has seen the movie Mean Girls? Caleb, nice, alright, we'll do a quick summary of the movie here. So the main character, as you can see there, her name's Katie Heron. So this movie is going over her first time in a public high school experience, and the reason this is sort of unique is because she's entering for the first time at the age of 16 years old after spending the first 15 years of her life being homeschooled in Africa because her parents are zoologists. And so we start the movie and she's going through her first days of high school, and she's having a tough time fitting in. It's pretty hard for her to make friends. Nobody's really giving her the time of day and introducing themselves to her. And that changes on the second day after a really rough first day where she ends up eating lunch alone by herself in the bathroom and just, having a really rough time with adjusting to the new school life. So on the second day, she meets her first friends who are named Damien and Janice. These guys are sort of outcasts in the school. And they show her around, they show her the different groups of people, where everybody sits at lunch, the kind of layout of the school where her classes are, and they introduce her to other people. And this includes the Plastics. So these are the other three girls that you see on the picture on the screen. These are your sort of like your A-list, stereotypical like mean girls from the title. Just kind of like your diva figures. They're the popular girls. And they actually invite Katie to hang out with them and eat lunch with her. And she's pretty hesitant at first because she just made her first two friends of high school and didn't want to leave them behind. But Damien and Janice actually encourage her to join the Plastics, and just so that she can get in on the group, learn all of their secrets, and that they can make fun of the Plastics behind their back and just have a good laugh at all the things that the Plastics do. So Katie ends up doing this, and it's going well at first. She's fitting in, she's kind of becoming one of the Plastics, and they're having a good laugh about all the stuff that they do. And this is all working until Katie ends up developing a crush on this kid in her calculus class. His name's Aaron, who happens to be Regina, the leader of the Plastics' ex-boyfriend. And so she learns about this, and she decides to take Aaron back for herself to kind of like stick it to Katie. And this upsets Katie, and she, let's see, the theme of revenge, she is just outraged that Regina would do this to her, and she just makes it her mission in life to get back at Regina for this. And the way she goes about that is just immersing herself in the group of being the Plastics, being a mean girl, and we kind of see her sort of take over the group from Regina and just really become a mean girl. At first it was sort of an act, but towards the end of the movie we see her just completely change, and she starts becoming one. And then it kind of blows up in her face, like there's just a big, bad stuff happens, but that's not too important here. So my rating on the movie, give it a 4 out of 5 stars. Can't give it a 5 out of 5. It's not how you do professional ratings. So it was pretty good. I think it had a big cultural impact for its time. It was pretty accurate. It was an interesting sort of storyline. I'm not probably the target audience of Mean Girls, but I sat there and I enjoyed it a little bit. So I thought, if I enjoy this, there's probably some people that are more tailored to this sort of movie that enjoyed it a lot more. So I gave it a 4 out of 5. Pretty solid movie all around. I would recommend giving it a watch, those of you who haven't. But now let's get into the main part of this, is the calculus. So ever since people have been hearing that I've been doing Mean Girls, they've been kind of intrigued, like, oh, what's the calculus in Mean Girls? Is there actually calculus? And so just so you guys know, I'm not just making this up out of thin air and stuff. I put some pictures here. Not the best quality pictures, so that's why there's not a lot in my presentation, but I put some here. We'll just go over. So Katie actually competes in her school's math league. This is at a state competition. Some more calculus we see is like right here. This is a picture of one of her tests, very blurry, but I was able to get uses technology, able to extrapolate some problems from these tests, and then you can see a lecture on the board from her teacher. We use a couple of those as well. So just so you guys know, I'm not, there is math in this movie, not just making it up. So the first example is off the whiteboard actually. I wrote this myself. And we have a series here you can see, and we're trying to figure out whether or not it converges or diverges. So let's get into the work here. So the way I went about doing this problem is first I wanted to manipulate the series in order to get it to a more ideal form to see if it was convergent or divergent. So the way I did this is, sorry, I didn't tell you guys the problem. So we have 3 over 2 to the n times 1 over 9 to the n plus 2. So I kind of changed this around. I manipulated it a little bit. So the way I did this is I split up the 9n plus 2 to 1 over 9 to the n times 9 squared. And then I kept going, so I got 1 over 81, then 3 halves to the nth times 1 over 9 to the nth. So 1 over 9 to the nth can also be written as the quantity of 1/9 to the nth power. And since I have two quantities to the nth, I combined them. You can see here, I cross multiplied these fractions, so my end product, I got 1 over 81, and then times 1/6 to the n. So you can see here, if you took calc, you see a pretty obvious example of a geometric series. And what we know about geometric series is that r, which is this value right here, if it is less than 1, we know that the series is going to converge. So we have our answer. I didn't do this, but let's say we want to take this further and see what it converged to. We could take the first term of this and divide it by 1 minus r, which is 1/6, and we can get what value that we converge to, but I said I did not do that. Next example, we have a differential equation that I took from one of Katie's tests I found. And we just have our derivative here, dy over dx is equal to 3x plus 2y plus 1. And we're asked to find the second derivative here. Pretty simple question. So I just rewrite the derivative on top, and when we are taking the derivative of this, the derivative of 3x, pretty simple. We just have 3, 2y plus 2 over dy over dx, the derivative, and then the 1 cancels, it goes to 0. And since we already have defined dy over dx, we can substitute that in here, which I did, you can see there. And then when we simplify this down, we get 6x plus 4y plus 5 as our second derivative of this. Now, pretty simple right there. Now here's the big math problem in the movie we see. So some backstory here. So she's at Katie is at her math league state championship. This is the third of 3 questions that are shown throughout the movie at this competition, and it's the final question shown. And so 1 versus 1, Katie versus a person from another school, and this will decide the winner of the state championship for the math competition. We have the limit as x approaches 0 of the natural log 1 minus x minus sine of x over 1 minus cosine squared of x. All right, first, I just did a quick graph visual of the function here. So Katie didn't have access to a calculator on this, so we'll go over the by hand to work in order to see that this does not exist, but we can just tell by this graph right here. As we approach 0 from the left-hand side, we're going to infinity. Then when we approach 0 from the right, the green arrow, we see that we're approaching negative infinity. So we know that the limit doesn't exist by that, but just since Katie didn't have a calculator, so we'll do this one by hand here. So first, when you have a limit equation, the easiest thing to do would be to substitute x here. And when we try to do that, we see that we obviously get division by 0, and we can't do that. So the next easiest thing is that we look to see if we can apply L'Hopital's rule. So the way we can see if we can do this is right here. We'll take the limit of the numerator as x approaches 0. We'll substitute 0 into that, and you can see I did that right here, and I got that equal to 0. Then we'll take the limit of the denominator. We'll substitute in 0. You can see I got 0 there as well. And since both the numerator and the denominator are approaching 0, we can apply L'Hopital's rule. And so what L'Hopital's rule allows us to do is we take the derivative of the numerator, and then the derivative of the denominator, which I did right here. Can't see. And I got, so the derivative of natural log 1 minus x, I got negative 1 over 1 minus x, and the derivative of sine is cosine. And then for the derivative of the denominator, the 1 goes to 0, so we don't have to worry about that. We have negative cosine squared x. So we use the chain rule here, and we get our derivative of negative 2 cosine x, sine of x. So we are going to try to see if we can substitute in 0 now. So we put 0 into the top, and we get a numerical value of negative 2. And then we plug in 0 on the bottom, and you can see we still have a 0. And since the top isn't approaching 0, infinity, or negative infinity, we can't reapply L'Hopital's rule, and since we have division by 0, we know that the limit does not exist for this question. And then, lastly, these are the other questions from the state competition that she was not exactly calculus questions, but still interesting, and we'll give them a look. Anyway, so I'll read this. Here, the first question that they had was, twice the larger of two numbers is 3 more than 5 times the smaller, and the sum of 4 times the larger and 3 times the smaller is 71. What are the numbers? So I had to read this a few times myself in order to kind of grasp the question here, but once you read it a couple of times and write this down as numbers and variables, it gets pretty simple to solve. So the written version of this in math terms is 2x equals 5y plus 3, and then we have 4x plus 3y is equal to 71. And so this is kind of nice because we have what 2x is defined, and when we have 4x, we know it's just 2 times 2x, so we can plug this in, and we can double this and substitute that in for 4x, which I did right here. And so we have 10y plus 6 plus 3y is equal to 71. Since we just have one variable now, it's pretty easy to solve for that. So we get 13y equals 65, y is equal to 5. We can resubstitute y in, pretty simple, and I did right here. So we have 2x equal to 28, x equal to 14. So we have our two numbers there. And then last question from the state competition was find an odd 3-digit number whose digits add up to 12. The digits are all different, and the difference between the two digits equals the difference between the last two digits. So again, kind of wordy, and I had to read this a few times, but it's again one that's pretty simple once you write everything down and get all that. So we know that a plus b plus c must equal 12. We know that a cannot equal b cannot equal c, and c cannot equal a. And we can also write down that a minus b is equal to b minus c and get an equation for b. And then since we know it's odd, we're just going to, and there's multiple right answers to this question, we'll just assume that c equals 1 to get one possible answer here. So when we assume c equals 1, and then a we know has to be an odd number and it cannot equal 1. So that limits our options to these 4 numbers here. So we're just plugged in each possible a to get all the combinations here, and the only combination that works is a equals 7, b equals 4, since we know that a plus b plus c has to equal 12, and that's the only combination that satisfies that. And so we get our number as 741, which is the correct answer. And then, yeah, again, not calculus, but still kind of interesting. And yeah, that wraps it up for the calculus inside of Mean Girls. Hope you guys enjoyed. Thanks for listening.